Hello everyone. This series of lectures we will be discussing about remote sensing for drought monitoring. This first lecture on the topic will be about introduction to drought concepts. Drought. We all have heard about this term drought in newspapers, news channels and everything. And we all know that drought occurs repeatedly even in all parts of the globe. Even some of us might have experienced drought like conditions. So this kind of droughts is now occurring in a more frequent manner with increased severity and in a widespread fashion, which can be attributed to change in climate. So the droughts, as we all know, when we discuss about droughts or when we read about droughts, we will always be thinking about from the perspective of human beings. But in addition to that, droughts will also affect the ecology and the environment. That is, the vegetation present, the animals present in the environment, all will be affected by droughts. So drought is nothing but a recurring natural hazard which causes a large-scale disturbance not only to the society but also to the ecology and environment. So what exactly is drought? This is kind of like a very really confusing question. That is, there exist multiple definition of droughts because of its complex nature. So there are many studies that has happened in the past which define droughts in different manner. And these definitions can be classified either as conceptual or operational. So conceptually, drought is considered as a period of below normal rainfall or water availability over a certain region. And we should be knowing this simple definition, that is, whenever there is a lack of rainfall or lack of water availability to us, we think that particular period as a drought period over our region. But this is kind of like really vague. That is, what exactly is a below normal rainfall? What exactly is below normal water availability? For how much time that sort of below normal condition should persist? All these things is not very clear from this definition. That is why we call this particular definition as conceptual definition. Conceptual definitions, we just get to know, okay, drought means a period when there is a lesser availability of water or lesser rainfall over a certain region. But it will not give us any information for practical drought monitoring and mitigation effects. That is, sorry, whenever a government agency wants to declare a certain region is undergoing a drought-like condition, then it has to first declare it. Then only it can start sending its relief material, divert its finances towards that region, all those things. So, for operational circumstances, there should be like a very clear definition. Okay, a drought can be defined only when a certain variable goes below this sort of threshold. So such sort of like operational drought definition should exist for lot various mitigation measures and also for various planning purposes. So there are multiple operational drought definition exist, and all those drought definitions aims to clearly define what is known as the onset of drought, what is the how the drought is expanding expanding spatially to different regions, how the drought is becoming like severe, and finally after a certain amount of time the drought will withdraw, and people has to really know, the government planners should know when the drought like conditions are withdrawing. So the operational drought definition will be or should be framed to clearly define the onset, spatial expansion, increase in severity, and withdrawal of drought events. And this particular operational definition will vary based on region and application. Say, for example, if you go and ask an agriculturist what is a drought, he or she may tell that amount of soil moisture value below a certain threshold is drought. Whereas if we go and ask a hydropower dam operator what is known as a drought, he may define drought in a different manner. That is, drought means the water level in the dam going below certain level. Such sort of definition exists. So for various applications, for different people, they will have multiple definition of droughts based on the application in which they have to use. That is why I said earlier that there exist multiple definitions of droughts, and these definitions vary region to region and with application to application. But the conceptual definition of drought is a below normal rainfall or water availability is like constant, which won't vary. But if we want to clearly say, okay, if this particular value goes below a certain threshold, then we can define a drought. Such sort of definitions will always vary with region and with application. And such kind of definition, what we call as operational drought definition. Then we will see how droughts can be classified. This also we should all be knowing, as we are like we should have read this in like our previous classes or something. So droughts can be basically classified into four kinds. The first and major drought classification is based on lack of rainfall. This is what we all will think. Okay, drought means lack of rainfall. So any lack of rainfall from normal condition, then we call that particular drought as meteorological drought. That is lack of rainfall. So the first classification is meteorological drought. Then if the meteorological drought extends for some more time, then the agricultural croplands may not have water, crops may begin to wilt. This condition, in which lack of soil moisture affects crop growth and crop productivity, we call that phase as soil moisture drought or agricultural drought. So soil moisture or agricultural drought is, is the phase in which the lack of moisture availability in the soil is affecting the crop productivity and crop growth. Then the third class of drought is hydrological drought. That is, in this phase, water will not be available in required amounts in different water sources. That is, we may be having reservoirs, we may having lakes, we may having rivers. So during hydrological droughts, the normal amount of water that we expect over these water resources will not be available, and it will be available only at a limited amount. This is hydrological droughts. So these three essentially talk about availability of water in different phases. First thing is lack of rainfall, second thing is lack of soil moisture, and third thing is lack of usable water that is available in different water sources. Then comes socio-economic drought. Socio-economic drought is basically the impacts of droughts. That is, when drought occurs and it extends over like a prolonged period, then it will start affecting our economic activities. That is, first agriculture will be affected, then all sort of industries which depends on water will be affected, and it will start affecting the social well-being. The amount of water available for our personal use will go down, and all these things will happen. This sort of phase in which the lack of water or the prolonged lack of water, when it starts affecting the social well-being and economic activities, that particular phase is called socio-economic drought. So these four are major class of drought as defined in literature. In some literature, people may have defined separately what is known as a groundwater drought. Sorry. So groundwater drought is nothing but very similar to hydrological drought, that is lack of groundwater resources. Say for example, we are having like a big agricultural area. There exists kind of like a meteorological drought over the region, but still the farmer can access groundwater, they can pump water, they can irrigate the field and have good crop growth. So the meteorological drought at that particular stage would not have transformed to soil moisture growth, because soil moisture is available and the crop grow to its fullest potential. However, if this particular pattern persists for some time, or even if like that particular farmers are move towards like really water intensive crop, then this kind of irrigation will be keep on happening, and slowly over a period of years the amount of groundwater available over the region will deplete, and the farmers who are depending on the groundwater will slowly begin to face the lack of proper water yield from the groundwater source. That is, the amount of water that is coming out of the aquifer will reduce. They have to install like a larger pump, they have to drill bore to a much deeper depth. All these things will happen. This phase some people call groundwater drought. Groundwater drought is a phase when the availability of groundwater becomes difficult. That is, the aquifer is yielding much lesser than before, or much less quantum of water is getting or coming out from the aquifer. However, since groundwater also is part of a hydrological cycle, some of the authors would have classified this along with hydrological drought, whereas some author might have classified this separately as a new kind of drought, that is groundwater drought. In addition to these classes of droughts, more recently there came a new term or a new classification known as ecological or environmental drought. That is, as I said in the first slide, drought not only affect human society, but if you look at all the previous definitions, the ultimate classification of drought is socio-economic drought. That is, we always think about from only a human perspective. However, if drought persists over a region for a really long time, or if the drought is extremely severe, then it will have a huge impact on the flora and fauna of a region. That is what trees may die over in the forest, water in available in streams and everything will reduce, which will affect the aquatic life. Lot of animals in the forest may not have water to drink and they may die. All these worst scenarios may happen. Or if the drought persists for really long time, it may lead to forest fire. This is what is happening in western US or in Australia. If a drought extends for a prolonged time, it may lead to forest fire. All these things will happen, and ultimately the flora and fauna of a region will be affected and they may undergo a irreversible transformation. That is, a whole forest, whole swath of forest, after a certain amount of drought, forest fire, all those events, the forest may disappear and it may be converted to a shrubland naturally. This can happen. So such irreversible phenomenon, when it happens, this sort of situation, people classify it as ecological or environmental drought, which affects the ecology, environment, and also the human beings. Because when a forest is getting converted to kind of a shrubland, then the services available from the forest to human beings will be affected. Forest will have like a major role to play in the water cycle. Forest will provide lot of materials for human consumption. All those things will be affected. So this particular classification of drought, ecological or environmental drought, takes into account the interconnection between humans and the natural environment, that is vegetation and animals, as well as humans, everything together, and any irreversible change occurring to the environment is what is due to drought events is what is classified as ecological or environmental droughts. This is kind of like a more recent definitions. There are like, if the bottom link in this particular slide may take you to like a much recent review paper in the topic. Okay, when we always talk about droughts, we will easily get confused with other following terms given in the slide. First thing, water scarcity, famines, heat waves, aridity, low flows, and desertification. All these terms and droughts are kind of, we will try to use it synonymously. That is, we will use one term instead of the other. However, these terms should not be confused with droughts as they are different. So in the next slide, we will see what is each term and how they are related to drought. First thing, water scarcity. Water scarcity is basically a supply and demand problem. That is, say if there is like an urban population living in a particular place, due to lack of water, that particular people living in the area might be suffering with water scarcity. That is, say there are like 100 people over is living in a given region. If water is supplied only to satisfy the needs of 50 people, that is water scarcity. So water scarcity is basically a demand and supply problem. This need not be actually a drought event. That is, a water scarcity can occur due to really large population, that is overpopulation, or improper water supply system. Water supply system may not be good enough to carry water. So water scarcity is not necessarily drought event. It is basically a demand supply problem. Then famines. Famines are extreme scarcity for food. So we might have heard about like Bengal famines during British period, or we might have heard about famines in African countries like Somalia, where people die due to lack of food. Famines are kind of like the worst scenario of drought. We all know that like droughts can cause famines. That is well understood. However, famines need not only occur due to drought. Famines can also occur due to human beings. That is the in some of the history textbooks, the authors might have said that the Great Bengal Famine happened during the British time period was basically due to the wrong policy of the British. That is, whatever that was cultivated from India was taken to foreign land, which caused lack of food to our own people and it led to the famine. So famines need not be the effect of drought. It can also be due to mismanagement of people or mismanagement of administration. Then comes heat waves. This is the most commonly confused term with drought. Heat wave is nothing but the prevalence of increased temperature above normal. Say this kind of news we might have heard, that is like in news they may give like a bulletin. The temperature is expected to be higher than normal for the next 2 to 3 days, or the temperature is expected to be below normal for 2 to 3 days. These kind of bulletins we might have heard in news channels, or even IMD, that is India Meteorological Department, will give such bulletins in their website. So this is what we call as heat wave. If the temperature is above normal, we call it as heat wave. If the temperature is below normal, we call it as cold wave. So essentially this is nothing but the prevalence of higher temperature than normal. Say for example, on a given region, during like May month, if the temperature is supposed to be like 32 degrees Celsius, the maximum temperature, if the temperature goes up to 35 degrees Celsius for a certain amount of time, say for 4 days or 5 days, we call that as heat waves. That is increased temperature prevalent over a given amount of time. However, such heat wave events are often short-lived. That is, it may be occurring for a period of few days to 1 or 2 weeks. That's all. Whereas a drought can be kind of occurring over like months or even years together. So essentially, heat wave is just a kind of increased temperature, but it is kind of like a short-lived. It will occur over a period of like 1 or 2 weeks. That's all. Then comes aridity. People will always think arid region as undergoing kind of like a permanent drought. That is not the case. Aridity refers to a climatic phenomenon. If a region is arid, then that particular region is supposed to receive much lesser rainfall than a humid region. And that is a permanent phenomenon. Permanent in the sense like in the order of human lives I'm talking about. It may change in climatological or geological time scale. However, in like our lifetime, if a place is classified as arid, that region is supposed to receive much lower rainfall. It doesn't necessarily mean that region is undergoing a drought event. A drought event is a temporary, it's episodic event. It can happen for like a few months or even for a few years, then at some point it will vanish. Whereas aridity of a region is kind of like a permanent, it is a climatological characteristic of that particular region. Say for example, our Thar desert is climatologically arid. It will receive much lower rainfall than other parts of India. So that is aridity, that's a climate characteristic. It does not necessarily mean that particular region is undergoing drought. Then comes low flows. Low flows is essentially means reduced water flow in streams and rivers. If people see certain rivers and say, oh, water is flowing in a much lower manner, it is need not necessarily represent a drought even. It can even be due to seasonal phenomenon. That is, during monsoonal rainfall, we may see all streams running with its full glory. Then after some time, it will slowly diminish. Then during like non-rainy season, there may be much lesser water or even no water. So this sort of low flow can be seasonal. It can represent the hydrology of that particular catchment. It need not be a drought event. Then comes desertification. So desertification is nothing but reduction of vegetation in a region due to mismanagement. Let us say like a region that is already kind of like a semi-arid or arid region. So semi-arid and arid region, always we know that there will be lack of water and there will be very good potential for water to evaporate. That is, air over that particular region will be dry. It can suck out whatever moisture is available in the surface. So let us say some people are like irrigating that particular land with groundwater, and groundwater can contain lot of salt. So what will happen if the people is pumping groundwater, irrigating the land, that particular water will evaporate, crop will grow. But over say like 1 or 2 decades, what will happen is all the salt from the groundwater will be deposited on the ground. The ground will turn saline, and slowly over a period of years that particular saline ground will not be suitable for any vegetation. So vegetation will completely disappear from that part of land. So this sort of thing, with this due to mismanagement, when a growth of vegetation over a region is reduced, or if the growth of vegetation is completely removed from a region, then we call that as desertification. So desertification also can occur even in a non-drought areas. However, all these can occur simultaneously with drought or can be an impact of drought. Say for example, first we will talk about like aridity. We said like Thar desert is arid. Yes, we all know. Maybe the rainfall there may be say like 200 to 300 millimeters per year. However, if a certain year, if Thar desert receives only 50 millimeter of rainfall, that we call that as drought event. If something goes below normal, we call that as drought event. So all these like drought can occur simultaneously with all these. That is, if drought extends for a prolonged period of time, it can lead to water scarcity. If drought extends for like very long, like 2 to 3 years, it can lead to famines. Droughts and heat waves can occur together. That is, lack of rainfall plus increase in temperature can occur together. Low flows, extended period of drought can dry up all the water available and rivers may get dried out. It can occur. It's kind of like an impact. Desertification, again, it can be an impact of drought. So all these previous terms, water scarcity, famines, heat waves, aridity, low flows, desertification, they are different. However, all these or some of these can occur simultaneously with drought, or some of them can be an impact of drought. That is, desertification is an impact of drought. Low flows is an impact of drought. All these things can happen. Okay, then we will see drought development. So essentially, drought begins with lack of rainfall. So so whatever be like a region, in general, drought will begin with a lack of rainfall. So we will start with lack of rainfall, that is meteorological drought. If that particular meteorological drought occurs over a certain period of extended time, say over like 1 or 2 months, especially if it happens during the growing season, say like for us there is two growing seasons in India. One is Kharif, June to September, then another thing is Rabi, mostly from November to January or February, something of that sort. So if a lack of rainfall, if like instead of raining in say July, if it doesn't rain, then what will happen? Crops will already be there, and whatever moisture available in land will be used up by the crop. After some time, that particular land parcel or that particular region will be completely devoid of soil moisture. Then this particular lack of rainfall is now will be converted to soil moisture drought. That is the next phase. So the crops will wilt, productivity will go down. If this particular lack of rainfall extends over like 6 months or 1 year, then whatever water available in the reservoirs, dams, lakes and everything might have been used up, which will lead to hydrological drought. After this, if this hydrological drought still extends for like very long period of time, lack of rainfall, lack of crop productivity, or like the reduced crop productivity and lack of water available in different water sources, if all these things continue for a prolonged period of time, it will finally have an impact in the quality of life, that is we call as socioeconomic drought. So in general, drought begins with meteorological drought. It slowly translates itself into uh, soil moisture drought, then progresses to hydrological drought, and finally it impacts the society, which we classify as socio-economic drought. Then we will see the anthropogenic influence on drought. Humans, we are and we can influence the water cycle to a great extent. That is, we can what to say, change the land cover of a region completely. Say like what is happening in like Amazon rainforest destruction. That is, people are clearing huge swath of rainforest converting into rangeland for animals to graze or cropland. So that is complete change in land cover. Or if people starts large scale irrigation, that is what is happening in kind of like Indo-Gangetic belt or in California, what is happening, large scale irrigation over like entire state or 2-3 states combined together. Water abstraction, take all the water available from a river, use it for our own use like agriculture, personal needs and all those things. Build lot of dams, block water and all this. So all these things are influence of humans on the water cycle. So essentially humans can induce, that is create new drought event, or exacerbate. Exacerbate means to make it, to increase its severity. We can increase the severity of drought or even sometimes mitigate, that is reduce the effect of droughts. So this is what we are going to see now. Okay, this particular figure is kind of like a small summary of whatever I have said for anthropogenic responses. That is basically we just saw drought occurs because of lack of rainfall. That is basically due to climate variability or like weather pattern changes, all these things. So that will lead to meteorological drought. And if we change the land use so much, like kind of we are like changing the land cover to from forest, or we are causing like deforestation, we are planting huge swaths of cropland, all those things are happening, it will lead to soil moisture drought. Then we will apply irrigation with this, take all the water from the nearby river, pump groundwater and all those things. Then after a certain period of time, all those water sources will kind of like get dried out. So essentially all the human activities that is given here, all the human activities given here, change in land use, applying irrigation, construction of water management or water regulation structures, abstraction of waters, all these things will have a say in water available for future use or even water available for people living in the adjacent states or something together. So humans through their action can induce or reduce or increase the effect of droughts. In addition to this, all these human actions can influence the occurrence of rain itself. We call it as kind of like land atmosphere feedback. We will see briefly about it in the last slide. So humans can influence the amount of moisture available in the atmosphere, which will ultimately influence the amount of rainfall over region. In addition to that, like the anthropogenic climate change, that is due to increased CO2, climate itself is changing, which is causing change in rainfall pattern naturally. So all these human activities can change the nature and occurrence of droughts. And what scientists are telling us, hereafter, whenever we talk about droughts, whenever we design systems for drought monitoring or drought predictions, we must always take into account the action of human beings. We should not think humans as a separate entity and drought as a natural entity, but we should always put all those human influences. That is, if you are trying to model the hydrology over a region, we should always take into account what are all the dams, how much water is getting abstracted for various uses. All those human activities should be taken into account before we study or try to predict different drought events. Okay, the next concept we are going to see is flash drought. So droughts are often occurs gradually. That is, drought will take some amount of time to onset and also to withdraw. It's not kind of like an instantaneous event. It will take like a few months for the effects of drought to be felt. Slowly it will occur. Then it will slowly withdraw after like a good rainfall event. So this is why drought is more commonly known as a creeping disaster. It creeps, it comes in really slowly. And many people would have thought, since it, or many people will think, since it comes slowly, it is very difficult to identify it. However, it is now observed, that is now in the sense like in the recent past few years, it is observed that lack of rainfall combined with high evaporative demand of the atmosphere can make the drought intensify much rapidly. And these type of rapidly intensifying droughts are known as flash droughts. So flash droughts are kind of recently identified events. They are kind of occurring from even like past times, but now only we are kind of recognizing it. That is lack of rainfall. If there is like a lack of rainfall, then crop should die or crop productivity should go down, water resources should dry up, and all these things will take at least 1 or 2 months for us to realize. However, if this lack of rainfall is suddenly combined with high evaporative demand of atmosphere, that is temperature can increase, that is heat wave can set in along with lack of rainfall, or there can be like a sudden period where there is very high amount of wind flowing, or there can be a sudden period where there is a really high amount of sunshine available over a region. All these things can happen. So any sort of phenomena that is which can increase the evaporative demand of that particular atmosphere over a region, it can introduce or it can make the drought to become intensify in a much rapid manner, and this is a flash drought. So flash droughts typically sets in the order of like say 2 weeks or 3 weeks maximum, not even in the order of months but 2 to 3 weeks. So flash droughts can have a severe impact even before we can identify it. If you look at some of the drought monitoring systems in certain parts of globe, they will give one map every month. Okay, this is the drought kind of situation this month. This is the situation next month. However, flash drought will set in within 2 weeks or 3 weeks. So within, even before we realize, drought might have expanded over a large swath of region with the increased severity. So flash droughts can have severe impact even before we identify it. And this flash drought is what is explained in this particular slide. Okay, so let us assume a region where there is good amount of water available for crops to grow. Say like take this as like India itself. Say like people might have just planted their kharif crop and they might have given the first dose of irrigation for the crop to grow initially, thinking that okay, we will receive rainfall next week. So that is our scenario. What we are thinking is soil moisture is available initially, and then comes the lack of rainfall. That is, first people might have planted crops, supplied some water to it, thinking that rainfall will happen soon, but that particular rainfall is not occurring. We all know that during monsoon months, if there is no rainfall, there will be clear skies, so good amount of solar radiation will happen, which will like increase the evaporative demand. We all know, like when we studied evapotranspiration, we came to know that ET is influenced by temperature, that is air temperature. ET is also influenced by wind speed and solar radiation. So these three weather parameters will affect evapotranspiration. Increase in temperature will increase ET, increase in wind speed will increase ET, and also increase in solar radiation will increase ET. So any one of the three or even all three can happen. If such thing happens and if the evaporative demand of the area increases, so evaporative demand goes up. If that happens, what it does mean, like the evaporative demand is what is given in this brown dotted line. So evaporative demand is increasing. Since the evaporative demand of the atmosphere is increasing and since moisture is available in the surface, actual ET also will increase. More water will go to the atmosphere and soil will dry up. After a certain period of time, after like few days itself, due to lack of rainfall or due to like lack of irrigation, whatever, that particular land might have dried up and ET will start reducing. However, if this high evaporative demand persists continuously, like this high temperature or high solar radiation persists continuously, the evaporative demand will be keep on growing. That is, atmosphere is becoming more and more drier. However, there is no water in the soil to evaporate. So this phenomenon can happen within few days, 3 to 4 days, or even like 1 or 2 weeks. It can happen with the region which had like enough soil moisture before, due to lack of rainfall and increased evaporative demand of atmosphere combined together, it can turn dry very soon. And if it happens say within like initial period of crop growth, crop will die and that particular stage itself, it will never grow. So that initial, so this sort of very fast occurring drought is what is known as flash drought, and flash drought can have severe impact on agriculture. Say if it happens as in the example what we have seen just now, if it happens during the initial phase of crop growth, then the crop will never grow, which will turn into complete failure of agricultural productivity. So flash droughts are kind of uh, people have started looking at much more recently, and they need kind of a very new way of thinking to monitor them. And just one more thing, for semi-arid regions, say semi-arid regions means there may not be enough water available. People might be just requiring, or people might be praying to rain god, please rain. It can like start in this particular phase itself. Like there need not be like enough water available. There can already be high evaporative demand. So that sort of semi-arid region or arid region can much quickly go into flash drought kind of conditions. They need not even take 2 to 3 weeks. They can even undergo like severe drought like events, and crop can die within even 1 week of time. So whether it is a humid region, whether water is available or not, whether it is arid region, doesn't matter. Flash droughts, if lack of precipitation or lack of water availability, if it combines with increased demand of atmosphere, it can lead to flash drought. Just remember one thing in this stage, flash droughts typically occurs when droughts or lack of precipitation and heat waves are combined together. However, heat waves need not be the only reason for increase in evaporative demand. The increase in evaporative demand can, as I said, can be either due to completely clear skies bringing in monosolar radiation, or sudden increase in wind speed due to certain anomalous phenomenon in the atmosphere. All these things can happen. But droughts, that is lack of precipitation, when it's combined with heat waves, more likely it may go towards this sort of flash drought situation. Okay, what is the basis of drought occurrence, or what is the causative factor for droughts? Rainfall is basically the major reason for drought to occur, that or the lack of rainfall is the major reason for drought to occur. So rainfall occurs because of moisture available in the atmosphere. That is, a rain will fall over region only when water is available in the atmosphere. Water should be present in clouds, then only it can rain. And this moisture, this water is transported to different parts of the globe through the circulation of the atmosphere. That is, atmosphere is not in a stable stationary state, it is keep on circulating itself. So there is lot of water that is evaporating from oceans, from land and everything. All this evaporated water goes to the atmosphere. It gets carried away by atmospheric wind and everything to different parts of globe. Then it will fall as rain over certain parcels of land, certain regions. So this is what we call as general circulation of atmosphere. Any disturbance to this atmospheric circulation will cause shift in this pattern and change the rainfall quantity and spatial distribution. That is, suddenly if say for example take Indian monsoon. Typically Indian monsoon means what, like Indian summer monsoon, the moisture laden winds from the Indian Ocean should enter the Indian landmass, and it should come with good amount of moisture, and then it should deposit the moisture as rainfall over our country. This is basically we know about Indian monsoon. Say for some reason, if this particular wind, if it doesn't go deep into India, say like say I'm drawing like this, say the southern part of India, the winds are expected to come from Kerala. It will slowly move to where, what to say, East India, and then it will take a turn towards north and everything. Say if for some reason the wind is like not taking a turn like this here, somewhat it is kind of going in a different direction, or if all the moisture might have been deposited on this stage itself, then what will happen? This particular wind pattern that should reach the northern parts of India might not have gone, and rainfall over the region might have changed. So these sort of things can happen. Whatever happens to this atmospheric motion, if it disturbs atmospheric motion, that will affect the rainfall. And also occurrence of certain global events, say like El Nino, which is like anomalous temperature patterns in the Pacific Ocean. Such sort of things can happen which will affect the atmospheric uh, circulation or atmospheric motion. That can also have a say in amount of rainfall. So we have a concept, say this is not a climatology course, but if you study like climatology or some other related courses, you might have come across a term what is known as a teleconnection. Say here in this slide we will see a teleconnection. Teleconnection is nothing but whatever happens in one particular part of globe, it will affect the weather pattern in another part of globe. Say this particular slide is an example for that. In this particular slide, what is depicted is the correlation between El Nino that has occurred over southern Pacific region, that is here. Yeah, in this particular region, and its relationship between the rainfall in the consequent month, that is El Nino happened in January, February, March, and rainfall, or this is a drought index PDSA, we will talk later. Basically think about rainfall in kind of like June, July, August of the subsequent period. So if there's you can see like very strong negative correlation here, very strong negative correlation here, over this part, over this part, over here, and all those things. So negative correlation means if the El Nino gets much stronger, all these marked red marked portions will undergo like severe meteorological drought, like water amount of rainfall will be affected or amount of water availability will be affected. On the other hand, this particular portion having a positive correlation where there will be more availability of water. So increase or anomalous temperature over this region will cause increased water availability over here, whereas it will cause decreased water availability over here, here, and these lands and all. So this is what is called as teleconnection. Say Africa and this Pacific Ocean is much far. However, whatever is happening in this particular portion of globe is affecting what is happening in this part of globe. So this is what we know as teleconnection, and people who are working in like meteorology or climatology will take into account all these factors when they try to model or forecast drought events. In addition to this sort of like climatic phenomena or global phenomena, even uh, the land atmospheric feedback between over the region itself can have a say in what to say, increase or decrease in drought severity over a region. That is, say for example, this can happen like uh, whenever water is available over region, we all know that particular water can evaporate. So whenever water evaporates, it infuses moisture into the atmosphere, and that moisture can at some point of time can fall as rainfall, which can reduce the drought. Like whenever rainfall falls, it can take away the drought like conditions. However, this sort of feedback between land can actually increase or decrease the severity of drought. Say as I said, for this flash drought events, say some land moisture may be available, drought can set in, all the moisture from the region can be sucked up, that is evaporation will be happening, all the moisture might have been taken away, then that particular parcel of land will be completely dry. And we all know whenever portion a land surface is not having any water, whatever the heat from the land, it will be transferred to the atmosphere in terms of sensible heat flux. Like in evaporation in ET class we learnt about this term, sensible heat flux, that is transfer of heat in terms of rise in temperature, that is through convective motion. When heat is transferred from land surface to atmosphere, like in the form of sensible heat flux, then more amount of heat will go from land to atmosphere. Atmosphere will get much more drier, that is its humidity will further decrease, which will amplify the effect, which will worsen the drought. So this is kind of like a feedback, this is what we call it as feedback. Whatever happens in the surface will affect the atmospheric pattern. So the feedback can be two types, one is positive feedback and one is negative feedback. So positive feedback is, say if say drought is occurring, And if the what is happening between the land surface and atmosphere, if this is going to increase the drought, we call that as positive feedback. Positive means whatever the event might have started it, if that event becomes more severe due to this feedback, we call that feedback as positive feedback. Say if a drought has set in, that has dried up the atmosphere, and the land surface is heating up the atmosphere more and more, it will set up kind of like a positive feedback, and it will make the drought more severe. On the other hand, say for example, some hypothetical example, a drought has set in, no lack of rainfall, evaporative demand has increased, but somehow people are managing to bring in more water continuously and keeping the land surface wet throughout. If that happens, due to this increased demand in increased evaporative demand, water will be keep on evaporating and more amount of moisture will be added to atmosphere. If more moisture is added to atmosphere, at certain point of time, that will come down as rain, which will remove this drought event. So if this feedback removes that particular event which triggered it, then we call that feedback as negative feedback. So that is why the land atmospheric feedback can either worsen drought condition, that is through positive feedback, or mitigate drought condition, that is negative feedback. So a drought can occur basically due to the what's a disturbance in atmospheric circulation pattern, but this particular drought can be amplified or reduced in intensity through land atmospheric feedbacks. So this brings us to the end of this particular lecture. In this particular lecture, we got introduced to the definition of drought, that is the conceptual definition we heard, but the operational definition, as I said, it will vary, and based on the application there are multiple definitions of drought. Then we saw classification of droughts, that is meteorological, soil moisture drought, hydrological drought, socio-economic drought. We also got introduced to what is known as a groundwater drought, and also the new term ecological or environmental drought. Then we came to know what is known as a flash drought. That is, flash drought are nothing but the droughts which can intensify very rapidly in the order of 2 to 3 weeks. Then we came to know how humans can influence drought events and the necessary to bring in the effect of human beings in the water cycle when we study about droughts or water cycle itself. Then finally we just got introduced to a glimpse of how droughts can occur basically, and what is the role of land atmospheric feedback in amplifying or reducing the effect of drought. With this we end this lecture. Thank you for listening.